All right, so here's our review for the upcoming covalent compounds and molecular geometry test. Number one is saying when atoms bond and quote-unquote stick together, they're doing this bonding and sticking together using their valence electrons. So the valence electrons are the ones that are responsible for all of the bonding that's going on, whether they're being shared or transferred. It's the valence electrons that are responsible. Okay. Number two, we're going to identify whether it's ionic or covalent. You'll need to know the differences between the two. Okay, so the type of bond where the electrons are shared, that's a key component. Sharing is a covalent compound. When electrons are transferred, that is an ionic compound, so between metals and nonmetals. So shared is between two nonmetals. Transferred, ionic is between metals and nonmetals. Type of compound where molecules are formed, that is called a covalent compound. Cations and anions are formed. So a cation is a positively charged ion. Anions are negatively charged anions. And these are formed in ionic bonds. Those that occur between two nonmetals, we just mentioned that here, between two nonmetals, that is a covalent compound. Between a metal and a nonmetal, we just mentioned that right here, that is an ionic compound. Okay. All right, so moving on, we've got a diagram here that shows two atoms. We aren't quite sure what they are yet, but it's showing me an electron here, an electron here in their valence shell. Now it goes on to mention that the electrons are being shared. Okay, that's a key right there. And what it's doing is it's forming a bond because of that sharing of electrons. So we can see that these two atoms sort of overlap each other. The two electrons are being shared. It even goes on to mention that this is a molecule. All of these are signs of a covalent compound. So this is showing me the process of a covalent bond being formed. On the right, I've got the same or similar things where I've got an atom and an electron. Over here, I've got another atom and an electron. But what's different about these is that this electron is being transferred to this atom. And it even mentions here that there's a transfer of electrons. So that is a key. It also goes on to say that after they bond, there's a positive ion and a negative ion formed. So all of these are signs that an ionic compound has been formed. So a positive ion, we mentioned up above, is a cation. And a negative ion is an anion. So that means that this must be a metal and this must be a nonmetal, which means these must be two nonmetals. All right, down here, number 3. Again, with the ionic covalent, we need to be certain of our differences between the two. So which one uses prefixes? The only one that uses prefixes in the naming system, those are covalent compounds. The ones that use the crisscross charges to get the formula, that is ionic. So when I cross the positive and the negative charges to form subscripts, that's an ionic formula. Also called a molecular compound, that is covalent. Those types of compounds that do not use prefixes are ionic. Remember, covalent uses prefixes. Ionic does not. And those type of compounds that have polyatomic ions, those are also ionic. So anytime you have a PO4 or a NH4, these things are polyatomic ions. They automatically make the compound ionic. Okay, so now we're going to identify the compounds as ionic or covalent and then name them. So my first compound is MgCl2. So we're going to break it down. Magnesium and chlorine. Identify, are they metals, nonmetals, polyatomic, and then go from there. So magnesium is on the left of the periodic table. That makes it a metal. Chlorine is on the right side of the periodic table. That makes it a nonmetal. So the bond between a metal and a nonmetal is ionic. Okay? So that means I do not use prefixes. So I'm going to list the first full name of the metal, which is magnesium. And then the ending, the Cl, loses its INE in chlorine and gains IDE. So it becomes magnesium chloride. Okay. My next one is between, I've got Ca3 and PO4 2. Okay, so let's break it down here. What is Ca? Calcium. Calcium is a metal. What is PO4? Well, yes, it's a phosphorus and 4 oxygens, but as a group, as a unit, it is a polyatomic ion. So this is ionic, which means, again, no prefixes. So first full name of the metal, which is calcium, and then the full name of the polyatomic ion. So the polyatomic ions do not get IDE. We list their full name, whether they're at the back half of the formula or the front half, we list their full name. So this becomes calcium phosphate. Okay. Letter C, I've got a carbon and an oxygen. Carbon is a nonmetal. Oxygen is a nonmetal. So this is a covalent compound. Covalent compounds need prefixes. Okay, so when I look at my first element is carbon. There's only one carbon atom, and I know that because there's no subscript written here. Okay, it's implied that it's 1. So in a covalent compound, my first element always needs a prefix unless it's only one atom. And here I've got one atom of carbon, so all I need to do is just write the full name of carbon. And then let's move on to my second element, which is oxygen. The second element always needs a prefix. Even if it's 1 or 101, it needs a prefix. So there's no number written here as a subscript, so it's implied that it is 1. So the prefix for 1 is mono. I've got oxygen. I lose the end of oxygen and gain IDE, so it becomes monoxide or simply monoxide. Carbon monoxide. And my last one here, H2S. 2 hydrogens, 1 sulfur. Hydrogen is a nonmetal. Sulfur is also a nonmetal, so this is covalent. Okay, which means I need prefixes. So my first element is hydrogen. We said the first element never needs a prefix unless it is more than 1. 2 is more than 1. So the prefix meaning 2 is di, and the full name of the first element, hydrogen, and the second element, sulfur, always needs a prefix. And there's no number written here, so it's implied the number is 1. So the prefix meaning 1 is mono. We lose the ending of sulfur and add IDE, and it becomes monosulfide. Dihydrogen monosulfide. And the last two on this page, I'm given the name and I need to write the formula. Okay, so my first name is diphosphorus tetroxide. I can see prefixes, I can hear the prefixes. that automatically tells me that this is covalent. This is a covalent compound. So that means that the prefixes tell me how to write the formula. So di means 2. Phosphorus is referring to the phosphorus element. Tetra means 4. Oxide is meaning or referring to oxygen. So I've got 2 phosphorus atoms and 4 oxygen atoms. My formula is P2O4. Now, because this is a covalent compound, my subscripts cannot be reduced. So I cannot reduce this to PO2 because it's covalent. Covalent compounds cannot be reduced. So it stays P2O4, diphosphorus tetroxide. On the right, letter B, I've got a calcium plus 2 and PO4 minus 3. So now I've got ion charges. I've got a positive ion, a negative ion, a metal, a non-metal. So here's a metal. This is actually a polyatomic ion, just like we mentioned up above. So this is automatically ionic. So that means there are no prefixes. So the only way that I can figure out how to write the formula for this is the crisscross method. So if I take this 2 and I cross it over here, and the 3 crosses over here, my new subscript for calcium is a 2. And my new subscript for phosphate, PO4, is a 2, but I've got to separate them using parentheses. The 2 goes on the outside. So Ca2PO4, calcium phosphate. All right, on the back. On the back, we need to determine if my molecules, the structure, are written correctly or incorrectly. So a couple things. Carbon is always the center atom. Hydrogen is never a center atom. And all atoms need 8 valence electrons except for hydrogen. Hydrogen only needs 2. So we're going to look at the position of the atom and count the electrons. So starting with the first one here on the left, I've got HCN. So I've got carbon in my formula. So carbon should be in the center, and it is. Okay, so now let's count the electrons. Hydrogen has 2 electrons here in a single bond, so that's 2 plus 3, 4, 5, 6, 7, 8. Hydrogen here has 8 electrons. It only needs 2. It cannot not have more than 2. So that's our problem here. Hydrogen is drawn incorrectly. Carbon has a pair here, so that's 2, plus these 2 is 4, plus this double bond, which is another 4. Carbon has 8. Carbon's good. Nitrogen needs 8 as well, so here's 2, 4, 6, 8. Nitrogen has 8. It's good. Moving on, CHBr3. So here's my carbon. It should be in the center. But when I look, bromine is in the center. That's not correct if I have carbon in my formula. Carbon needs to be in the center. Okay, so that's my error here. So let's count to see if our electrons are good. Hydrogen can only have 2. A single bond shows me it's got 2. Bromine needs 8. Here's 2, 4, 6, 8. It's good. Bromine needs 8. Here's 2, 4, 6, 8. This bromine's good. Bromine in the center, even though it's drawn incorrectly, should have 8. Here's 2, 4, 6, 8. So everything else checks out with the exception of carbon not being in the center. Bromine should be moved over here. Okay, and the last one here on the right, CO. So again, carbon is in my formula, but if I've only got 2 atoms, there's really no true center. So I've only got carbon and oxygen. So now let's count electrons. Carbon needs 8. It's got 2 here, 2 here, 2 here, plus these 2 make 8. Carbon is good. Since oxygen is also sharing these 6, it's got 2, 4, 6, plus its own 2, making 8. That oxygen is good. So that molecule is drawn correctly. Okay, moving on. I need to know the Lewis structure for these 4 atoms, or molecules, excuse me. I need to know it for water, carbon dioxide, ammonia, and methane. So the formula for water is H2O. Dihydrogen monoxide. So water is, we've already talked about this, water is a bent molecule. Okay, it's never linear. So when I draw water, it's going to have an oxygen, a hydrogen, hydrogen, and single bonds between the 2. They are in a bent shape. Got a lone pair here and a lone pair here. So the lone pairs on the oxygen are causing the hydrogens to bend down. Okay, so this is a bent shape. H2O, dihydrogen monoxide. So how many total shared pairs? Well, there's a pair that's being shared here. There's a pair that's being shared here. So that's 1, 2, 2 shared pairs. How many total lone pairs, meaning unshared? Well, if these are being shared, that means these dots, these electrons are not shared. So here's a pair. Here's a pair. So that's 1, 2 pair. Okay, carbon dioxide. Carbon is 1 carbon. Di meaning 2 oxygen, so CO2. Carbon dioxide is similar to water in that it's got 3 atoms. So 2 oxygens, 1 carbon makes 3. 2 hydrogens, 1 oxygen makes 3. However, between the oxygen and the hydrogen, I've got single bonds. In this molecule, I've got double bonds between the 2. Double bonds are stronger than single bonds. So the carbon is going to hold up those oxygens with its strong double bonds, forming a linear shape. So carbon has 2, 4, 6, 8 electrons. It's happy. Oxygen has 4. 4. We need to draw lone pairs. So I've got a lone pair here and here, giving that oxygen 8. This oxygen has 2 lone pairs. It also has 8 now. So the total shared pairs, we got 2, 4 electrons, so that's 2 pair. And then 1, 2 more pair, giving me 4 shared pairs. How many lone pairs? Well, here's a pair here and here, that's 2 pair. Pair here and here, that's 2 more pair. So this also has 4 lone pairs. Ammonia. Ammonia is one that you'll need to know. It is NH3. Let me try to draw that better. There you go. NH3. So hydrogen is in my molecule. Hydrogen can never be a center atom. So that means nitrogen is. So N is my center, and I'm surrounded by 1, 2, 3 hydrogens. Hydrogen can only sustain 2 electrons, which means it can only get a single bond. So 3 single bonds, that means hydrogen's happy, this one's happy, this one's happy. Nitrogen, however, has 1, 2, 3 pairs, that's only 6 electrons. So I need to draw 2 more to give it 8. So how many shared pairs does it have? Well, it's got a pair here, here, and here. That makes 3 shared pairs. How many lone pairs? It's got 1 lone pair right up here, giving it 1. And our last one here is methane. So methane is carbon tetrahydride, CH4. So carbon is in my compound. It's a center element or atom then, and it's surrounded by 1, 2, 3, 4 carbons or hydrogens. So single bonds only for hydrogen. So hydrogen's got 2, it's happy. Hydrogen's got 2 electrons, it's happy, happy, happy. Carbon has 2, 4, 6, 8, it's also happy. Okay, so how many pairs are shared? Got 1 pair here, 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 and here. That makes 4. How many lone pairs? Well, I look at carbon, I look at hydrogen. I don't see any lone pairs here. They're all happy. So 0. Okay, so how do we explain the difference between polar and nonpolar? Polar means that the electrons are shared unequally, which means one atom is going to pull harder on the electrons than the other atom. Nonpolar means that the electrons will be shared equally, which means both atoms are pulling the same amount. So let's look at our example here. I've got hydrogen and hydrogen. These are the same atoms. So imagine as if you're playing tug of war with yourself. If you're playing yourself, you have the same height, same mass, same weight, same strength. No one is going to win. No one's going to win between these two atoms because they are identical. Okay, identical atoms will never have a tug of war winner. If that's the case, that means the electrons are shared equally. That makes this nonpolar. Okay, on the right, I've got a hydrogen and a bromine. So these are not the same atom. Okay, so bromine, I need to think which one has more electronegative or is more electronegative than the other. Bromine is further to the right on the periodic table. So that means that bromine has a higher electronegativity and hydrogen has a lower electronegativity, which means bromine is the stronger atom. If those two were playing tug of war, then bromine would win. So the dipole would look like this. The arrow would go to the winner. So that means that bromine would be slightly negative because it's pulling all the electrons. Hydrogen is slightly positive because its electrons are being pulled away from it. So this would be considered a polar molecule. And the last part is identifying the shapes and the geometry of the molecules. Okay, when I look over here at my first one on the left, this one right here, it looks like a dumbbell. Okay, this is between 2 atoms, so this is considered a diatomic molecule. Diatomic molecules always have the same shape. Okay, if you look at it, they kind of follow this line, a straight line. This is a linear shape. You cannot spell linear without line. Okay, they both are in the same line together. Diatomic molecules, two atoms. So anytime you have two atoms bonded together, whether they're the same or different, they will always be linear in shape. Okay? The next one is also linear because it follows a straight line. Okay? Now, this one has a double bond here and a double bond here, which keeps it in the straight shape. So this is one that we have seen before. This is an example of carbon dioxide. CO2 forms double bonds between the oxygens and the carbons. Another one that we should be familiar with is this one right here, where we got a center atom and then two attached atoms to the center. Now these are not in a straight line. These follow a bent pathway. So they are bent. So it kind of looks like a linear shape that was bent down. Okay, so this molecule actually has a lone pair here and a lone pair here. This example would be H2O, water. So water molecules are always bent. Carbon dioxide molecules are always linear. Moving further to the right, here's my center atom. And I've got 1, 2, 3, 4 atoms bonded to the center. So the prefix meaning 4 is tetra. The only type of molecule that we've talked about that has tetra in the name is a tetrahedral. Tetrahedral. So a tetrahedral example could be methane, CH4, which we drew up above. Now, the two that are on the bottom are a little trickier, okay? So both of them have 1, 2, 3 atoms bonded to the center. 1, 2, 3 atoms bonded to the center. So in this case, they are both trigonal. This one's trigonal, this one's trigonal, or trigonal, depending on how you want to pronounce it. Okay? Now, this one on the left is flat. Okay, this one is flat. It kind of looks like a propeller. And propellers go on airplanes. So this one is trigonal planar. Planar because it's flat. I used the reference as a plane propeller, even though it's not referring to the same thing, but that's what it looks like. On the right, this one is also, well, by process of elimination, we know what it is, but it's got 1, 2, 3, so it's trigonal. Here's my center atom. And just by looking at it, if you can imagine, it looks like this one is raised up a little bit. So the way that it's raised up, it kind of looks like a pyramid. So this one is trigonal pyramidal. Trigonal pyramidal. So familiarize yourselves with the shapes, maybe some examples. One other thing, the trigonal pyramidal, this one has, and I didn't draw them, I should have, This one has a lone pair here on the end. So an example of this molecule would be ammonia, NH3. NH3. So the four that we need to know: NH3, ammonia, trigonal pyramidal, CH4, methane, tetrahedral, H2O, bent, CO2, carbon dioxide, linear. Familiarize yourselves with the shapes of the molecules, the names of the molecules, and the common molecules like carbon dioxide, water, CH4, methane, and ammonia.